You already know the answer your culture gave you. You've heard the religious version, the philosophical version, the version your family believes. You've probably settled into some combination of all three. What you almost certainly haven't heard is what the science actually found when it tried to answer the question directly. Not near-death experience testimonials collected from people who believed in the afterlife. Not philosophical thought experiments. Actual measurements. EEG readings taken from patients as their hearts stopped, brain scans from the moment of cardiac arrest, data collected from dying brains in real time by researchers who were not trying to prove anything except what happens. What they found is strange enough that none of the existing frameworks, religious, philosophical, or materialist, fully accounts for it. The question, what happens when you die, turns out to be more complicated than anyone on either side of the debate wants to admit. I was looking into the neuroscience of consciousness when I kept running into the same set of studies. I expected to find a straightforward story. I didn't find one. The answer turned out not to be a single discovery, but three separate lines of evidence that don't fit together as neatly as expected. So I went deeper. Death, it turns out, is not an event. It's a process. There are two clinical definitions. Circulatory death, the heart stops and breathing ceases permanently. Brain death, all functions of the entire brain, including the brainstem, irreversibly shut down. Either counts legally and medically. But what happens between those 2 points is not the empty silence most people imagine. In the minutes after the heart stops, the body enters what biologists call active dying. Cells begin to break down through a process called autolysis. Enzymes that once maintained cellular function turn inward and begin digesting the cells from inside. Oxygen deprivation triggers a cascade of chemical signals. Muscles, deprived of ATP, begin to stiffen. The process is orderly, sequential, and extraordinarily complex. But the brain does something unexpected. A 2023 study published in the Proceedings of the National Academy of Sciences monitored the brain activity of 4 dying patients using EEG. 2 of them, within seconds of cardiac arrest, showed a sudden, dramatic surge in high-frequency brain activity, specifically gamma oscillations. In one patient, the increase ranged from 2-fold to nearly 400-fold above baseline. Gamma waves are strongly associated with conscious perception, memory retrieval, and dreaming in a healthy brain. By some accounts, among the closest neural correlates of conscious experience we have been able to measure. The dying brain wasn't going quiet. It was, briefly, going louder than it had been in life. Here's the strange part. In a large-scale study led by Dr. Sam Parnia at New York University Langone Medical Center, published in 2023, researchers monitored 567 cardiac arrest patients across the United States and United Kingdom. Of those who survived, 28 were well enough to be interviewed. About 39% reported memories or perceptions, suggesting some form of awareness while they were clinically dead. Roughly 21% described what the researchers called transcendent recalled experiences of death, the classic features people associate with near-death experiences: a sense of separation from the body, moving toward light, encounters with deceased relatives, a life review in which years of memories compressed into what felt like seconds. The research team also placed hidden visual targets near the ceiling in resuscitation areas, images that would only be visible from above. The idea was simple. If patients were genuinely perceiving their environment from outside their bodies, some of them should be able to describe what they saw. One patient, approximately 3.5% of those tested, correctly identified an auditory stimulus presented during resuscitation. No one identified the visual image. This is not proof of anything, but it is not nothing either. The data exists. The experiences are reported consistently, cross-culturally, by people with no reason to coordinate their accounts. What the brain is doing during those minutes, and why the experience, whatever it is, takes the shape it takes, remains genuinely unresolved. There is one case researchers still struggle to explain. Vicky Umapeg was born prematurely in the early 1950s, so early and so small that, as was common practice at the time, she was placed in an oxygen incubator. The oxygen concentration was not properly regulated. Vicky was given too much, and the resulting damage to her optic nerves left her completely and permanently blind. She never saw light, she never saw shadows. In her own words, nothing, no light, no shadows, no nothing, ever. In 1973, when she was in her early 20s and working as a musician in Seattle, she was seriously injured in a car accident. Her heart stopped. She was clinically dead. What she later described to researcher Kenneth Ring, who documented her case in a 1997 study conducted at the University of Connecticut, is this. She found herself above her own body, looking down. She described the operating room with specific details. She described her own body. The length of her hair, the ring she was wearing, the appearance of her hands. Then she described moving upward, through the ceiling, into what she experienced as a luminous environment. She described seeing. For a woman who had never in her life had any visual experience whatsoever, no optic nerve function, no light perception, no understanding of what seeing even meant in any embodied sense, she returned from a 4-minute clinical death with visual memories. Ring, not a believer himself but a careful researcher, argued that her account could not easily be explained as confabulation or wishful imagination. She had no reference point for vision from which to construct it. He documented her case. He could not explain it. She died in 2022. The honest position on what happens when you die requires sitting with a tension that most people, on both sides of this question, would rather resolve quickly. The materialist position that consciousness is entirely produced by the brain and that when the brain dies, consciousness ends, is the default position of neuroscience. It is well supported by decades of evidence showing that every change in brain activity produces a corresponding change in experience, and vice versa. It is a reasonable position, but the data from dying brains complicates it. The surge of gamma activity in the seconds after cardiac arrest is not currently explained. The consistency of near-death experience reports across cultures, ages, and religious beliefs, including from people like Vicky, whose experience cannot be attributed to prior visual imagination, does not fit neatly into the framework. The religious position, that consciousness survives death in some form, is not falsified by the evidence either, but it is also not confirmed. The data is consistent with the hypothesis, but consistency is not proof. What the science has established is this: the dying brain is more active than previously understood, death unfolds over more time than previously assumed, and the experiences reported by people who return from clinical death share features that the field cannot yet account for. Whether any of that means something persists, whether there is something it is like to die, in the way there is something it is like to be alive, remains one of the few genuinely open questions in modern science. Vicky Umipeg saw something in 1973 that her eyes were physically incapable of showing her. The EEG of a dying brain surges with the same frequencies strongly associated with conscious experience in a living one. 39% of people who come back from cardiac arrest report some form of awareness during the time they were clinically dead. None of this answers the question, but it changes what the question is. Not, is there life after death? A question that may be unanswerable, but something more immediate and more unsettling. What is actually happening in those final minutes? We have better instruments than we used to. We are measuring things we couldn't measure before. And what we're finding is that the moment we assumed was the end may be considerably more complicated than anyone imagined.